Hello, nice to see you again. I'm Chris, and this is my second tutorial of Festo.CMMT servo drive. In last video, I show you how to use Festo's automation suite to commissioning and set some parameters with the current state, reset your drive, some commissioning operations. In this video, I will show you how to use a Beckhoff PLC that it is a gray IAPC with model number C6920 to configure a EtherCAT master, and then to make the connections with our servo drives, Festo servo drives, as a EtherCAT slave. Okay, let's start. As you see here, there's a white Ethernet cable is connecting to the downside, to the upper of the servo drive, so it is used for the EtherCAT communications. And these two cables, the blue cables, will connect to a switch hub. That is for me to do the commissioning. Okay, so let's start. Here I open my Festo software, but I'll show you again. I'll just start again. Festo. Open the Festo software. It will spend around 10 seconds something. And I'll show you device scan functions. You can upload the device from your servo drive to your PC. So just select the device scan functions, and there's two devices of scan in my network. The first one is our servo drive, the second one is the HMI. So what we need to do is we select this one, the servo drive, and then choose add to project. After that, automation suite will initializing the plugin and the descriptions and all the parameters. Okay, gray is still some okay. This import. So after that, we just need to click the home button, and here is our drive, and double click it. Then again, the software will open all the parameters in here. Great. So it means all the parameters we upload from the drive to our PC. That's great. Okay, after that we need to download a ESI file. So by config a EtherCAT network, you need a ESI file that is provided from the manufacturer. In this case, it's Festo. So what you need to do in here, you need to go to Google and search Festo.CMMT-ST CIA402, and then you can find a link can help you to jump to the Festo support portal. Just open it. And then you can slow down. You can find a device description files for EtherCAT XML. Just download it to your computer and import to your environment. In this case, with TrinCAT. Okay, so now we can start to use TrinCAT. Just a second. Okay, so here is our TrinCAT project. For the first thing, we need to import the ESI file to our environments. Okay, we do. We can. So where's my mouse? I lose my mouse. Come on. Okay, here. And we can go to PC, C drive, or the location to install the TrinCAT system, and go to TrinCAT 3.1, and then config IO and EtherCAT, and then just put the ESI file or XML file that you download from Festo's homepage to this patch. And after that, you can open the TrinCAT. You open your TrinCAT project, and then go to TrinCAT and EtherCAT device, and reload device description to reload all your files. That's great. Okay, the next one, we can import our EtherCAT master. So how to do it? Easy. It's IO, right? Just open here, and device, right click, add new items, choose EtherCAT master, and there's a two. Because in my PC I have two adapters, network adapters, then you choose. I choose the first one, and then you can open the EtherCAT master to confirm is really that what you want or not. But this case for me is okay. So first step is done, and then now we can add the slave. Just right click here. You can scan, but I prefer use manual because you can know what device you exactly like to insert into your network. Right click, add new items. Okay, so in here, just close this one, and open the Festo and CMMT-ST, and a pop-up is shown here. You can just choose NC configurations to automatically add the NC access to your project. After that, you can see motion in NC task. The access is inserted in your project automatically. Great. So there's one thing you need to confirm, that you can need to click on your CMMT-ST drive and then open the DC tab, and then make sure DC for synchronization is enabled. This function is very important. Okay, now we can add a PLC project. Just go to PLC, right click, add new items, add a standard project here, and then right click here. So the first thing, now our PLC project is created. The first thing is we need to create a global variable list that with some variables that need to link to our server drive. We'll go to GBLS, right click, add, and then global variable list, and open it. Zoom it a little bit bigger. Okay, so first one is IFMI mode, add %I stomach as SINT. Do the same one as MI mode as stomach Q, %Q stomach SINT is equal to 8. And then I will define access. Festo access is equal to access REF. Okay, but now because I didn't import my library, so the reason now is a no fine. We'll add the library now. For the reference, right click, add library, and just search MC power. Then we know the library we want to add is TC2MC. TC2MC2. Just click this one and open. Okay, now see no error is displayed anymore. Then we can build our project. Because this time I would like to use Trinkets library to control our server drive, so I need to set to 8. And then yes, we need to do the mapping. Go to input and output. There's a mode of operation display. Just right click, change name, and search MSI, and then choose it as the input that we define. Okay, here same. Okay, done. And then we need to link this access reference to our real hardware. How to do it? Go to open the access. Open it. I think it's access 1. Then there is a tab called settings. Inside the link to IO and link to PLC. Link to IO is that mean the real hardware is what I link to. The real link to PLC is which variables will link to the variables. Okay, click here. Then you can see a Festo access. That's what we defined before. Just click OK. Save it. Done. So the basic configuration is okay, but there's one more options. Some parameters you need to set. The first one is the encoder. Open the encoder and go to parameter. By default it's 0.001, but it depends on what you set on the server drives. So open the Festo automation suite again, go to field bus, and then you can see position is -6. -6 is minus 0.0000150 here. So what you do, you need to match this setting with our Trinket system, copy it, and go back to our Trinket system, Trinket here, and then copy, paste here. Okay, great. And then you need to go to drives. So there's so many settings you need to match the actual drive. It not depends too much on here. For example, the reference speed, I believe it's 1740. Let's save it. Make sure no error. Okay, the basic configuration is done. Then we can download configurations to our Trinket system. Great. Turn to run mode. And okay, and then log in. Okay, so now it's log in here. You can just play button, And here you can open the Festo access. NC to PLC is mean the data from the drive to your PLC. PLC to NC is the other directions, opposite directions. Over here you can see some really change here. You can see the actual value. You can see this, the operation mode. You can see so many details in here. It means the communication is okay. The next step, we can try to programming all the points main. I think I tried to program all the stuff just in main, but in every application it's better to use some FB or create a new point and to group what you want to do. Okay, so the first one, I will define some function blocks in instant here. The first one is MC power. It's the block to help you to turn on your drive. Then you need a bit for enable it. Okay, the second one is you need to joke. You have a joke operation, right? MC joke. And then you need to have a signal the speed of the joke operation. It's a 64-bit of floating number, the field number, and then you need a forward FW and joke BW. Both is a bool. Okay. And then you will need a home operations, MC home, and you need a bit to trigger it, so it should be bool. Okay. And then you will need a block for absolute moving, MC move ABS. Okay. And then you will need a bit to trigger it, and then you will need the set point, the position set point, PIPUSITION, and you will need a speed set point also. It will be 64-bit real variables. Okay. And then you will have a relative moving, LMV.move, MC.move, move move MVR, yes, here. Then you will also need a bit to trigger it, EXE is a bool. And then you will need a set point, distance set point, DANCE is also will need a speed, LE speed. It should be also same. I think I need to delete this one. Okay. Okay, then you need a reset data block. Reset function block. MC reset, and then you need a bit to trigger it. Okay. And then you need to read the current position. So here's the current MC read. Actual position. It should be MC read actual position. Then you will need a trigger bit. Okay, and this bool, and MC read actual position value. Okay, and then you will also have a read actual speed, MC read velocity, MC read actual, not EXE, is a trigger bit, and also and value is a feedback value. Okay, finally you will need a function block to read all the status. So it's read is MC underscore read status, is MC read status. So you have a bit to trigger it. Okay, status, and then you will have my status is your current status. My status is equal to ST not access status, okay. So, and then by default I would like to turn some bit to on, because this is I don't want to turn on so much bit in here by menu. For example, this one, I'll do true. It will be true, true, and also here maybe also will be true. Oops, boot is this boot type with true. Okay, great. And basically finish, and then we can try to read the data, the status in here. The first one, I would like to read the current position, so it will be mc.read current position, and access, oops, and access is equal to gvl.festo.access. For the enable is equal to mc read actual position exe, and then I need to get back my value, so I will use position bos ion is equal to mc read actual position value. Great. And then if an error is happened while I reading, use this function block, then I can just reset the bit. But actually maybe your application you can check so many conditions, or you can trigger it more after 1 second or 2 seconds, but in tutorial I just directly to false. Great. And second one, I would like to read the actual speed. Also access is equal to gvl.festo access, and enable is equal to mc read as actual velocity no dot underscore is exe. And then for the actual speed, I would like to feed back to a variable mc read actual v. Great. And then this will be great. And then I will turn on my, I will read the status, read status. Access is equal to gvl.festo status. Enable is, oops, enable is equal to mc read status exe. And then I would like to get my feedback status is equal to mc equal to my status. Oh, same here. If mc.read actual position read actual v dot error, then I will right here pop up in here. I will close it and error, then I just mc, oops, and then just copy this one here to false. Okay, and here same, if mc reads status dot error, just do the same things, put it in here, and I just put this one to false again, right? Okay, great. Just turn, okay, now just download project first time. Great, now you can see I read the current position, I read the current speed, and then I read the status. For the status, if you open the my status variables, you can see all the values received. It's great. The next one, I would like to reset my drive and turn on my drive. So I call mc reset first. Access is equal to gvl.festo reset.festo access, and then I would like to execute it. Execute is equal to mc.reset exe, and then if mc reset have any error, or mc reset is busy, it means it's executing, then I can reset the execute bit. So mc reset exe is equal to false. False is equal to false. Then I would like to have a power. MC power is to turn on my drive. MC power access is equal to gvel.festo access. And for the enable is mc power unenable. And I would like to turn on the possible directions and the negative directions also. Negative is equal to true, and positive is also equal to true. If there is any error, then what I need to do, I need to reset my MC power enable flag. Great. Oh, I don't need these two. I grab my error. I will down the project in here first to make sure no error is running here. Just press OK and OK. Great. And now I can reset my drive first. So I will turn on here and my camera, and just turn on my trinket here again. Go here. Okay, SoC in here. I just put a little bit small here, and then do to see my drive. I will reset my drive first. Okay, the drive is reset. I will turn on it. And you see the green, the LED is changed from flash to on. It means your drive is turned on. Okay, after the drive is turned on, now we can try to move it. Let's go back to here. First I will show you how to make the jog applications. I'll delete this one. MCY. Okay, MC. For the first one, for the jog, I would like to change the jog mode. Jog.mode is equal to ejog.mc jog mode continuous. It means that for this mode, I can choose the speed of the jog operation will depends on what you pass inside to the function block. Okay, and then we can just call it MC jog access is equal to gvel.festo, and for the jog backward is equal to MC jog backward. Jog forward is equal to MC jog forward. Jog forward. And then for the speed, just MC jog speed. Great. It should work. Then just if MC jog dot error, then we can reset the trigger bit. MC jog backward is equal to false. MC jog forward is equal to false. LSD. Okay. Then we can download it to test it. Oops, there's something I missed it. We need to add some interlock here, right? So what kind of interlock we need to hear is and my status is operational. It means the drive can be operational and knock MC jog forward, right? So the same here, and my status dot operational and knock MC jog backward. So what you need to do here, we just download, and then adjust the screen here. We can backward. Oops, why? Something's because I didn't enter the speed. Okay, for example 1.1 mm per second. Just turn the backward again. Grace is backwarding, and then we can forward. Now also forward. Okay, so jog operation is finished. The next one I would like to home it. So MC home dot mode dot homing mode the best one is maybe you can use the function block from Festo, but for the tutorial I just make anything to be easy, so I just use the most easy homing mode. Is called directly, so mc homing mode dot direct. Then we can home it by access is equal to gvl.festo. gvl.festo. Okay, and execute is equal to mchome.execute. It should work, and I think this is enough. So if there is any error in the home operations, mc home.error or mchome.busy, then we can reset our trigger fed equal to false. Then we can end if. Great. Okay, so after home, then can check it by download the program. Okay, so just trigger it. Now just open my status. Sorry, the screen is a bit small in here, but there is a variable called home. Yeah, here. This one is turned to true. It means that the position home. You can do the positioning now. The first thing I'll show you is the absolute positioning. MC move, MC ABS. Access is equal to gvl.festo, and exe is execute is mc.abs exe, and position is mc.abs position, and speed is mc.abs speed. Okay, great. And that's not enough, right? We need to add my status. Now it's operational, and it's home, and not my status dot job. It means that now it should be operational, it should be home, and not other job is executing. It makes sense, right? Then if mc abs dot error or mc abs dot busy, then we can reset it to false. Great. Okay, then we can turn on, we can download it to the project, and then let's see here. Now the operation condition is okay. For example, now we can check the current position here. Now the check current position. Where is current position? Okay, just a second. Where is the current position? Okay. And my stage, see here, I don't know why. Just a second. The current position is 0, 2. Okay, it works. For example, now I would like to turn it on to 0 and with 1.1 milli per second. Then I can just turn it on. Okay, because now it's 0. So for example, I'd like to turn to 5 mm. Then I can turn it to on. It running to 5 mm, I think. Yes, you see, now it's 5 mm, so I mean it works. Okay, so finally I'll show you how to use the relative moving. It's also very simple. MC REL, then call it access is equal to access is equal to gvl.festo access, and execute is equal to mc rel execute, and then distance is equal to mc rel distance. Finally, speed is equal speed v is equal to mc RL speed. Great. And if mc any error happen, or it's busy, then what we need to do is we can reset the execute flag, and then just add some interlock here, and my status, make sure now it's operational and it's homed and not have any job. Oops, has job. Okay, great. Just download again. Error. Oops, there's one more. And if here, just download again. Great. And just put the screen here. For example, I would like to run speed at 1.4 mm per second, and every time I would like to run 3 vmm. And then we can go back to here. Now it's 5, right? So when I think here there's a also here it's actual position, DBS position, actual position here. Yes. Then when I trigger one time, it will stop at 8 mm. Great. And one more time, 11. Okay. So when I plus minus 3 in here, it should be go back to 8 something. Great. Okay, so everything's finished. It is very simple point-to-point positioning, and I think you know this is a very basic step of motion control. But I hope you like this video, and I hope I can see you again. Please like my video and share to some guys that you think is useful for him, and don't forget to subscribe and turn on the notifications. Okay, thanks, and I hope you can see you in the next video. Have a good day. Bye bye.